All right. So yeah, we're gonna definitely get a refresher of synthetic and long division. And this is gonna be one of those days where if you feel super comfortable with it after the first example or two, then you're gonna get the chance to go and start working on stuff. And if you're not very comfortable with it yet, you'll get another chance to see some more examples or get some guided practice. So today we want to be able to divide polynomials using long division and synthetic division. We want to use the remainder theorem to evaluate a function and use the factor theorem to determine if a value is a factor of a polynomial. So here we go. Grab your notes and let's get started here. So this is 2.3. And the section is entitled Remainder and Factor Theorems. Remainder and factor theorems. Okay. So before we can do a lot with remainder and factor theorems, though, we do need to make sure that we can effectively use synthetic and long division. So we're going to start with an example using long division. We are going to do 4x to the third minus 3x plus 2 divided by x minus 1. Okay. So setting up long division looks just like setting up long division kind of did when you were doing long division in elementary school. You start with your division bar, and then with long division of a polynomial, we have to go in descending order of powers of x, and if there's any power of x missing, like here we're missing x squared, there is no x squared value, we have to add in a 0x squared. So I'm going to go 4x to the third plus 0x squared minus 3x plus 2. So we have to have that as a placeholder. Okay, and then we're dividing it by x minus 1. So when we're doing long division, we think, okay, what would I have to multiply this value by, this x, to get it to be equal to 4x to the third? Well, x times 4x squared gives me 4x to the third. So I write 4x squared up here, and then I multiply this 4x squared by each of these terms. So we end up with 4x to the third plus, or actually minus, because it's -1 here. -1 times 4x squared is -4x squared. Okay, so then I'm subtracting here. 4x to the third minus 4x to the third is 0, as it should be, because you want that to be 0. 0x squared minus -4x squared is +4x squared. Okay, so we subtract, and then we bring down the next term, minus 3x. So now we have to think, okay, what would I multiply this by to get it to equal 4x squared? Well, x times 4x would give us 4x squared, so I go plus 4x. And then we do that same process again where I multiply this by each of these values. 4x times x is 4x squared. 4x times -1 is minus 4x. Then I'm subtracting 4x squared minus 4x squared is 0. -3x minus -4x is +1x. All right, and then we bring down the last number, plus 2. And we go, okay, what do I have to multiply x by to get it to be x? Well, x times 1 is x. So I multiply this by 1, and we get x minus 1 here. And then we're subtracting, so x minus x is 0. 2 minus negative 1 is 3. But I don't have any more terms left to bring down, so I write the rest of it as a remainder. But I don't want to put just like remainder 3. I want to continue writing this as though it's still, a polynomial. So I'm going to go plus 3 over x minus 1, because that's what's left over here. 3 over the original, x minus 1. So this would be my answer when I divide these polynomials using long division. Okay. So hopefully that's kind of jogging our memories here as to what long division is and how you do it. We're going to do the same problem with synthetic division and show how synthetic division is different, but essentially does the same thing. Okay, so synthetic division, we're doing the same problem. Okay, so with synthetic division, I'm going to rewrite it real quick. 4x to the third minus 3x plus 2 divided by x minus 1. So synthetic division is the one where you set it up with like the box in the corner. And the thing that you're putting in that box in the corner is the opposite sign of whatever this is. So since this is minus 1, I'm going to put a positive 1 in my box in the corner. The thing that most people tend to like about synthetic division is that instead of subtracting rows, you can add the rows. But anyway, now we're going to take the coefficients here, the 4, the negative 3, and the 2, and we're going to line them up here. Except since there is no x squared term, I do need to still put in a 0 as a placeholder for my x squared term. So 4 is the x cubed, 0 is the x squared, negative 3 is the x, and 2 is the constant. So we line up all our coefficients, the same as the coefficients that were here in our long division problem. Okay. So now we get started. The first value, you just bring it down. And then you go, okay, that value that you brought down times the number in the box, that number goes right here. Then you add them and bring it down. 0 plus 4 is 4. And then you multiply again. You go 4 times the number in the box. Still 4. That's the number that goes there. Then we add these. Negative 3 plus 4 is 1. 1 times 1 is 1. And then 2 plus 1 is 3. So now we have these numbers here, and these are going to be the coefficients on our new, or on our answer. So since this started with an x to the third, we're going to now start with x squared. So I'm going to attach an x squared here, an x here, nothing here, and then this is my remainder. So we're going to get 4x squared plus 4x plus 1 plus 3 over x minus 1. So you still stick the remainder over the divisor there. So we get the same thing. This method is typically faster, but it's a little bit harder to see how and why it works, and it might be a little bit harder to keep track of stuff. You can use either method. I don't care which one you use because they both get you the same answer. But yeah, so that's a brief overview again of synthetic and long division. We can do more examples of that in just a moment for those of you who would like them. But I am also going to mention the remainder and factor theorems here. So first of all, the remainder theorem. Okay, so the remainder theorem says if f of x is divisible by x minus c, and the remainder, or is divided by, not divisible by, if f of x is being divided by x minus c, and the remainder are is such that r equals f of c. So the remainder is equivalent to the value of the function evaluated at c. So for example, if we were using this in the above equation that, or in the above division that we did, sorry, one moment. So if we were doing this as in the above equation, the remainder here was 3, right? And we were dividing by x minus 1, right? So that would tell me that f of 1 is equal to 3. Since we were dividing by x minus 1. So whatever the remainder is, the value that you're dividing by, the function evaluated at that value is equal to the remainder. So that's kind of nice. You don't have to go back and do like plug in a value. You can do synthetic division or long division. And this is called synthetic substitution as well. So, I mean, you can evaluate f of x at c by dividing by x minus c. So we can evaluate f of x at c by dividing by x minus c and finding the remainder. So that's the remainder theorem. And then there's also the factor theorem. And you might be familiar with the factor theorem from advanced algebra trig. The factor theorem says that if f of x is divided by x minus c, and there is no remainder, then x minus c is a factor of f of x. And that's because f of c then would be 0. So this is kind of a corollary almost to the remainder theorem. And, oh, sorry, you guys can't see that. This is something that follows from the remainder theorem. If the remainder is 0, then that would tell you that f of c is 0. So c is a 0 of the function, which tells you that this x minus c is a factor of your polynomial. So for example, in the one above, since we had a remainder, that means that x minus 1 is not a factor of 4x cubed minus 3x plus 2. And that also tells me that 1 is not a zero of that function. Okay, so that's the factor theorem and the remainder theorem. Any questions so far? Any numbers that don't quite make sense? Anything like that? Okay. All right. So for those of you who feel like you're ready for the assignment now, I am going to post that. For those of you who would like to see more examples of long division and synthetic division, you can stick around and we will do more examples. But for those of you who feel ready, I do want to give you the opportunity to start working on the assignment. So, my goodness, why is my computer freaking out and making noises? Okay. So our assignment today is 2 IXL sections. We have one where we're dividing polynomials. It says using long division. I don't care if you use long division or synthetic division. IXL is not going to know which division you used. So that's the first one. And then the second one is evaluate polynomials using synthetic division. And again, I don't care if you use synthetic or long division, whichever one you feel most comfortable with. So this is practice using the remainder theorem. And then this one's just practice dividing. Okay, so if you feel comfortable and ready to go, you're free to head out and work on the assignment. If you'd rather see some more examples, stick around and I will be doing more examples. We'll start with this one here that's on the screen. Okay, so this one here on the screen is, it says h of v equals 10v squared plus 24v minus 23. And we want to find h of -3. So for synthetic division, how do you know which number to put in the box? Oh, good question. So in this case, for this particular problem, you would put -3 in the box. It's whatever you're dividing by. So if I was dividing by x minus 1, like we were in our example, then you put positive 1 in the box. So it's the opposite sign of whatever you're dividing by, essentially. So like here, it was the opposite sign. Since this was x minus 1, you divide by, or you put a positive 1 in the box. If you were dividing by x plus 5, you would put a -5 in the box. If you're dividing by x minus 99, you would put a positive 99 in the box. But in this case, when they phrase it like this, when they say find h of -3, that means that we're taking this and we're dividing by x minus -3, which is also known as x plus 3. So -3 is actually the number that we end up putting in the box. So when they ask you for h of -3, put -3 in the box. It's just all about how it's differently phrased. Okay, and then for this one, we start off with 10, 24, and -23 across the top. Because there are no skipped values. Like we have v squared, v, and then nothing. So the first number, we bring it down. Then we multiply -3 times 10, and we get -30, and that's what goes here. And then we add them, and we get -6. -6 times -3 is +18. Then we add them, and we get -5. So this number, our remainder, is what h of -3 is. And if I wanted to write out what this is equal to, I'd get 10x minus 6 minus 5 over x plus 3. Or v plus 3. Sorry, it had v's in it, so it'd be 10v minus 6 minus 5 over v plus 3. So this is how I would write my answer if I was asked for what my new polynomial is. But since I'm just asked to evaluate h of -3, my answer would be -5. Okay. So any questions about that one? Did that particular example make sense? Okay. Yeah, and if at any point you feel like you've seen enough examples, you are free to go. I'll probably do another one or two. So this one, we want to go, let's see, it's g of z equals 9z squared plus 26z plus 40. And we want to find g of -2. So -2 goes in the box. And then we have 9, 26, and 40. Yeah, I can do it with long division. Let's do this one with long division. So that's how you would set it up if you were going to do synthetic for this one. But we'll do this one with long division. So with long division, we would be dividing by it's z minus choking. Z minus -2, which is also known as z plus 2. All right. So to go from z to 9z squared, we would multiply by 9z. So then I would multiply this through to both of these. So we get 9z squared, and then 9z times 2 is 18z. Then we're subtracting. So these subtracted would give me 0. 26z minus 18z would give me 8z. Then we bring down the 40. And z, we have to figure out what do we multiply z by to get 8z. And it's just 8. So 8 times z is 8z. 8 times 2 is 16. Then we subtract. 8z minus 8z is 0. 40 minus 16 is 24. 24 is my remainder. So I would rewrite it as 24 over z plus 2. And since that's my remainder, then g of -2 would be equal to 24. So if we want to do that by long division, we can do it that way. If we wanted to do it synthetically real quick, we'd bring down the 9. 9 times -2 is -18. Add these and we get 8. 8 times -2 is -16. Add these and we get 24. And we get the same coefficients as we got here. So they both work the same way pretty much. They're just two different methods. They both get you the same answer. So that one, our answer would be 24. With these divide using long division ones, this one's a pretty short one. We'll do that example and then, yeah, and then if anyone wants to see more, we can talk about it. 16b minus 96 divided by b minus 6. So with long division for this, 16b minus 96, b minus 6, multiply by 16 to get 16b. 16 times b is 16b. 16 times negative 6 is probably 96, but yep. So we subtract and we get 0 for both of these. So our answer here is just 16 for this first one. Okay. So anyway, that's all the examples I'll do for now, unless anyone wants another.